Good morning, students. So today we're going to solve question 23 from GATE CSE 2024 set 1. The question states that L1 and L2 are regular languages and L3 is a non-regular language. Now, which one of the following statements are always true? The is/are part here tells us that this is a MSQ type of question, multiple select question, and the always part tells us that every interpretation of all the options every reasonable interpretation of all the options must always be true, right? Must always be true. So let's go to every single option and then analyze from there, right? The first option states this. Let's write it in a separate place and then start from there. So this is the first option, which states to us that L1 is equals to L2 if and only if L1 intersection L2 complement is equals to phi, right? So that means, basically speaking, you can interpret it in a common mistake that students commit here is that they will imagine in their heads that L1 and L2 are of same sizes and then L2's complement is going to be taken like this. So as long as L1 any part of L1 is outside of L2, as long as any part of L1 is outside of L2, we cannot have this equality condition present here, right? So yes, that part at first glance that is correct. If it is outside of here, then it is going to come inside of the complement part. So intersection would not be phi. So for that to be the case, it must go inside of L2, right? And they imagine in their heads that yes, it goes inside of L2. So now the intersection of its complement would be phi, right? And it makes them equal. But the interpretation which they have done wrong is that L1 can be smaller than L2, right? That is a condition which can happen, which I have showed here, right? Suppose that A is smaller than B, right? Suppose that A is smaller than B and I were to place A inside of B. Now A would not have any intersection with B's complement, right? B's complement is an area outside of the circle for B, right? So it will not have any intersection with B's complement and it is going to give phi there. But here A is not equals to B. Here A is not equals to B. Right? Here A is not equals to B, rather A is a subset of B, right? So this statement is not always true. This statement is not always true, so its truth value is false, right? So its truth value is false. So let's write it here only. Its truth value is false. Now second option that we have is that L1 union L3 is not regular. Okay. So let's imagine different cases which can exist for this, and then we're going to get a good understanding of it, right? So first of all, every time when you are faced with something, right, like this, you can directly apply some predefined cases and then imagine from there, right? Union with regular language for all cases, right? Now your regular language have a unique case known as clean closure, right? L1 can be equal to your clean closure, right? And clean closure is the superset of all other languages. So L3 is going to be a subset of clean closure, right? So a union with clean closure, L3 is given as a non-regular language, right? So it is going to give you clean closure only, which again is regular, right? Regular, why? Because we can draw a simple finite automaton for it. With this is your alphabet and this is your starting state, right? So this is going to give, this is a very common example which you can think in your head that yes, it is not always the case when L1 union of a regular language with a non-regular language is going to give a non-regular language only, right? But that is a good way to understand, but I can give you a better understanding of it, at least the way I understand it, so that I can have some analytical framework in my head which I can apply in different places. So I'm going to explain that part also. I think it's going to be helpful, right? So basically I've written it down here. So if A and B are regular languages, I know that here B is considered as a non-regular language, L3 is given as a non-regular language, but let's consider both of them are regular languages and go with it. Union of A union B is always regular, and how it is proven that it is always regular? It is proven like this, that we can have a starting state. From the starting state we can commit epsilon transitions. Remember the fact, right? This part you must have studied, that epsilon transitions that are present inside of epsilon NFA and normal DFA all have same language power. So as long as you are able to draw an epsilon NFA, then you can say that yes, the language is regular. So we can draw epsilon transitions into A and into B, and from the end state of A we can draw an epsilon transition into a final end state like this, right? This is going to give you a very good pictorial representation, right? This is going to give this is giving us a NFA, and A has its own NFA because it is a regular language, so its NFA must exist. B must have its own NFA because it is also regular. So the whole NFA is constructed. So now we can state that yes, the whole language, that is A union B, that is given by this particular diagram. A union B, why? Because if every string of A can be interpreted like this, from a starting point you go here, and from there you go here, like this, and can for every element in the language of B it can go like this, right? So it is this whole thing is going to give you A union B, and it is a finite automaton, and hence we can say that the whole thing is regular. Now if B is given as non-regular languages, so its finite automaton cannot exist here, right? So generally the union of a regular language with a non-regular language does not give you a finite automaton, except for the edge case in which B is a subset of A, and that is the case which we have observed here, right? Here L3 was a subset of clean closure, right? It is given in the question, that is always we have to consider, right? With that being done, we can state conclusively that this statement, that L1 union L3 is not regular, is not really always true. So truth value for this is false, right? This is false. Now let's consider third statement. L3 complement is not regular. L3 complement is not regular. How can we consider that? So L3 complement not being regular can be understood in a way that, see, if let's imagine the opposite of it, that it is saying not regular, right? So we can imagine that L3 complement is regular is the statement, right? If I can prove that this statement is true or false, then I can have an answer for this statement also, right? With L3 complement is regular statement being present, so for any language which is regular, we can draw a finite automaton, right? So let's imagine that we have drawn a finite automaton here, and we have minimized it and converted it into a DFA, right? Deterministic finite automaton. In deterministic finite automatons, when we take the complement of that particular finite automaton, we get to a finite automaton which looks like this, in which all the non-end states have been converted into end state, all non-end states have been converted into end states, and the end state itself has been converted into a normal non-end state, right? This is the complement for that language, right? So if we have the finite automaton for L3 complement, we can have the finite automaton for its complement also, right? So if this is the diagram for L3 complement, so this is going to be the diagram of L3, just L3. And as soon as we get the diagram for L3, then we can say that L3 is a regular language. Now that is a contradiction to the starting assumption which the question has imposed upon us, that L3 must be a non-regular language. L3 must be a non-regular language. So this line of reasoning, which with all deductions are correct, so the final initial assumption that we posed, that L3 complement is regular, must be wrong. So this statement has a truth value of false, so this statement has a truth value of true, right? So let's write it there in the question itself. It has a truth value of true. Now the fourth option states that L1 complement union L2 complement is regular, right? L1 complement union L2 complement is regular. Now we know that if L1 is a regular language, then L1's complement is also regular. L1's complement, why? Because I just explained it over here. If L3 basically being present here, whatever, this is some language A, so its complement, we can draw the diagram for its complement also. We can draw the finite automaton for its complement also. So we get a finite automaton. Finite automaton being present for a language means that it is regular, right? I explained this whole part just right. If you are not able to understand it, please rewatch this section again of the video. I think I have explained it good enough. Let's see. Right now we know that for complements the regularity still remains, and union of two regular languages is always regular. This is also something which I have shown here, right? Union of two regular languages is also gives us a finite automaton, hence that is also regular, right? So that is present giving us where is it, here it is, right? So this whole thing must also be regular, right? As this expression is regular, so this statement is true. This statement has a truth value of true. So let's write it on top of there, right? The truth value of here is true. Now they have asked us that we have to give the statements with the truth value true, right, which are always true as mentioned over here. So now we have that the answer for this question is C and D. I mean, I hope that you understood what I'm trying to explain here, and I think I've explained it good enough only, because I understand it like this and I've explained it in the same way. If you like the video, please like and subscribe to the channel, and happy learning. Have a good day.